Hello everyone, in this video I'll show you how to approach and solve projectile motions. This is an example of a projectile motion. So projectile motion usually forms a parabola, and as you can see here in this figure, this is a cannon. It fires a cannonball. The initial velocity at this height, at the muzzle of the cannon, is 40 meters per second. So the projectile motions, the speeds on the other side of the parabola, so if you draw a line of symmetry, the speeds are the same at each height. So if at this height, as you can see at the muzzle, it's 40 meters per second. Here at the same height, it's also 40 meters per second. Here at the same height, it's 30 meters per second. Here 30 meters per second here. But remember, the direction changes because the velocity is pointing this way now. But here the velocity is pointing down, right? This way. So this is very important. At the maximum height, the velocity Vy is 0. So remember that, because this, if we draw an X and Y, so this is X direction, that's Y direction. It's at this height, the velocity is Vy is 0, but Vx is constant. I have here some formulas and keynotes. These are very important. So all you have to do is you have to use these equations to solve projectile motion, and these are some of the key notes that you have to keep in mind. You have to remember these, because if you don't know these, it's going to be hard to solve these kinds of projectile problems. So the first one here is horizontal velocity is always the same. So in the X direction, the velocity is always the same. So that's why Vx, whenever we say Vx, okay, it means, so you have V initial and Vx or final. So the initial and the final are the same as the Vx, okay? So when you say Vx initial and final, it's always the same. So as it goes, this is very important because it never changes, okay? Because we assume no air resistance. Remember, when you say ideal situations, we just say there is no air resistance, so therefore the X velocity is always the same. Horizontal acceleration. So because the velocity is the same, the velocity is constant, right? Therefore, acceleration is always 0. Why? Because Ax is, right, the acceleration in the X direction is, you have Vx final minus Vx initial divided by time, right? So if you subtract them, you get 0 because they are the same, right? So 0 divided by time is 0 there. For acceleration is 0. So you have to keep that in mind. Projectile always experiences gravity. So Ay, so as it goes, Ay up and down is the same as negative 9.81. So if you pick up as positive, then it's down. So either you say down or negative. So negative means it's pointing down. It depends on which direction you choose as positive. Another one is if a projectile starts and lands in the same location or point. So remember, if you have a projectile motion that starts, and this is the ground, if it starts from here and just goes and back, sorry, it just goes here and comes back directly at the same spot, okay, then delta y is 0, okay, because it just goes up and comes back down. At the top, Vy is equal 0. So at this point or this point, it's all Vy is 0. At any height, as in the previous picture that I showed you, at these points, the velocities are the same. So remember that, it's very important. So here I have an example. It says driving off a cliff. So a driver on a car speeds horizontally off a 40-meter high cliff. How fast must the driver leave the cliff edge to land on a level ground below 100 meters from the base of the cliff? Ignore air resistance, assume down is positive, and ignore other forces. So we ignore air resistance, rotational forces, whatever. So first what you have to do is just write the knowns. What do we know about this? So we have a cliff here, okay, and the car is just okay, so it has only Vx. Remember, it's not going down, right? It's prevented by the ground. It's not going up, it just goes horizontally. It doesn't have Vy. That's the key here. So it just goes horizontally and it lands somewhere here, and we want it to land 100 meters away, and this cliff is 40 meters high. So delta y, right, the distance from here to the base, is equal to 40. Y initial is 0, we take down as positive, y final is 40. Now d, or the range, we are already given the range, right? So it's xf minus x initial is 100 meters, and as I said before here, Vy is equal to Vy initial is equal to 0, so there is no y here. So what do we know? What are the unknowns? So it's a Vx is the unknown, which is the same as initial speed, same as final, right? Because we said earlier that the horizontal speed doesn't change, it's just constant, it's just the same. In here, it's the same in here. It's all the same thing. So that's the key here as well. And formulas, the formula that we need, right? So the formula that we need is these two, this one and this one. So we need Vx. Vx is equal to d over t, right? We know the t, we don't know the t. We know the distance, but we don't know the t. Now, to find the t, we have to use this equation. And in this equation, we have Vy is equal to Vy initial is equal to 0. So this automatically goes to 0. And as we said, delta y is this one, right? Yf minus y initial. When you can move this, right, on the other side, it becomes delta y. So everything is set. So we have it here. I put it like this instead of y. So y final minus y equals y initial plus Vy naught times t plus half gt squared. So as you cross this becomes 0, and you move that, it becomes delta y equals 1 over 2 gt squared. And when you solve for t, you will get this. And when you substitute all the values, because we have delta y, which is 40, and we have g, right? The reason we have t here too, right? Because in projectile motions, as I said, right, it just go like this and come back, right? But you're already in this part, so what do you get? Times divided by this, and when you take it, it's 2.86 seconds. So it takes 2.86 seconds to head 100 meters away from the base. So once you have the time, you substitute it back into this equation. Vx equals d over t, 100 meters divided 2.86 seconds, you will get Vx equals 35.0 meters per second. So it's just that easy. All you have to know is just the things, write the knowns, and what are the things that you have to assume. Everything, when you write it, then it all becomes easy. You just look at the formulas and see how you can manipulate it. I have here another example with a diagram. I took these from a source here, this example, and I wrote the solutions here. So the example is a football is kicked at an angle 37 degrees with a velocity of 25 meters per second. So the ball is here, it's kicked at 37 degrees with a velocity of 25 meters per second. Now what you have to do, you have to calculate A, the maximum height, B, the time of travel before the ball hits the ground. So from here, as it hits the ground, the same level, you have to find the time there and how far away it hits the ground. Now the distance as well. You need to find the time, the distance, the maximum height. So what do we know? We know the angle, and we know the velocity that it's kicked. Okay, now the first one is to find the maximum height. To find the maximum height, we use this equation, right? Of equations that I showed you at the beginning of the video. So you use h as height, and then you have this formula. You substitute v because we have v, and theta, we have the theta, and g is known, right? It is the acceleration due to gravity, and you substitute it, you will get 11.5 meters. Okay, and the time of travel, for the time of travel we have this formula, t equals 2 v naught sine theta over g. So when you substitute 25 all the values, we have the velocity, we have the theta, and you have g, you will get 3.07 seconds. Okay, so all these equations are given, you just have to see how to apply them. That's all that there is to it. And then part C says how far away it hits the ground. So for that we have d, the distance or range, right? The range is from here to here. That's our range. Okay, range, right? So that's our range or distance. So we have that formula here, right? V naught squared times sine of 2 theta over g. Remember, these equations are not the same. Here for h we have v naught squared, here we have v naught alone, but and sine theta. This is sine squared, this is sine theta. Here it is v naught squared sine 2 theta. So once you have that, you substitute the values, the velocity and theta, and the acceleration due to gravity, then you will get a range of 61.2 meters. So that's our range. Now, the other two questions are just common sense, right? It says the velocity vector at the maximum height. So the maximum height here, right, there is no y component to this. So it's not just going there, it's just that just the y component reaches 0 here. Okay, it's not going up, it's not going down, it's just there, and the Vx is always the same, right? Vx stays the same, Vy changes over here. So for that, so since we know the top Vy is 0, so only Vx and Ax acts at the ball, therefore Vx is, you just use the Pythagorean theorem or sine this, right? So we have the angle, we have the velocity, 37, then you use sine and cosine to get Vx and Vy. So once you did that, you will get Vx equals V naught, right? V naught cosine of 37, and when you substitute the values, you get 20 meters per second for x, but for Vy you get 0 because the angle there at the top is 0, right? Because there is, it's just Vy is 0. Now for part E, the acceleration vector at maximum height. So the acceleration always stays the same regardless. So the acceleration is 9.8 here throughout the flight time. Okay, throughout the flight the acceleration is 9.81 meters per second. So it's down. Okay, so either you write down, or if you stated initially that down is negative and up is positive, then you get negative 9.81 meters per second squared. So I'll put some links in the description. You can just read further, and they are interactive. You can play with them and make sure you understand all the key aspects of the most important parts. Thanks for watching. Don't forget to subscribe.